Hello, everyone. Welcome to this webinar introducing our Canadian solar design tool with a focus on CNI self-consumption. We are going to wait a few more seconds to have all the registered people into the webinar. I'm just informing that all participants are muted and in listening mode only. And we are going to record this session, and we are emailing to all participants, even the one that doesn't have the chance to connect today. And we will have a Q&A session at the end of the webinar. To ask your question, please use the Q&A window, which is a separate window from the chat. So our team can collect all the questions. All questions are anonymous, and we're going to try to reply to all of them based on the timing and if we can end on time. But please try to use the dedicated window for Q&A. Let's wait some further seconds. Hopefully everyone is joining the webinar, and then we can officially start. So first of all, I present myself. I'm Andrea Pratico. I'm the Sales Director Europe for Residential Storage in Canadian Solar. And today we have also my colleague Ed Morak, which is the Technical Support Engineer for our Power Electronics department, let's say. So he will then introduce specifically the topic of today, so CNI self-consumption through our web design tool. And I will briefly introduce who we are, who's Canadian Solar, for the ones that doesn't know yet us as a company. And we have a mission, which is to power the world with solar energy and create better, cleaner Earth for future generation as Canadian Solar. Canadian Solar is one of the oldest company in the industry, in the solar industry. We are now actively doing business, let me say, more or less everywhere in the world. We have manufacturing plant, we have offices, sales, tech support offices, more or less everywhere in the world. You see here in the map all our presence through the EMEA region, but also Latin America, North America, Asia, APAC region, and so on. And as I said, we are one of the oldest company in this industry. We were founded in 2001 in Canada, Ontario. That's our headquarters. We are counting now more or less to 22,000 employees worldwide. And we shipped already close to 150 gigawatt of solar modules. And the interesting part, which is something new in the recent 2-3 years, we delivered already more or less 4 gigawatt hour of storage projects. And we have a crazy pipeline of 26 gigawatt of solar projects, but 66 gigawatt hour projects for storage in pipeline, which is really, really amazing. As EMEA, we were founded in 2009 in Munich. So our headquarters in Europe is Munich in Germany. And we have 4 offices and 3 warehouses. Offices based in Europe. We have also Madrid, we have Cape Town, and we have warehouses also in Middle East. In Europe, we have 2 warehouses, so we can support our partners locally in every region, in every country, with technical, legal, accounting, sales, marketing, logistic, and all the rest needed to run properly your activity and your business. So Canadian Solar has expanded its application and product portfolio widely, I would say, because a few years ago we were only focusing on those panels on the left, and now there's much more in our portfolio. So we integrated solar inverters, string inverters, hybrid only one storage systems for residential. We have AC batteries for CNI. We have DC batteries for utility scale. So we really completed our portfolio, being one supplier that can really provide most of the key components of a solar and storage system nowadays. We like to split our portfolio in the 3 main segments of the market. Residential, where we have obviously in each segment a dedicated line of modules, but now also inverters and storage systems. And For storage in residential, we do have EPCube, which is our only one residential storage. For the CNI, we do have all the complete line of our string inverters. We have KuBank, which is our AC battery for CNI projects. And on utility scale, we have obviously our string inverters for solar systems, and our SolBank, which is a DC battery, which is used for utility scale storage installations. As Canadian Solar, always more our focus is to be by your size at 360 degrees. So we are a real partner for our customers, doing several activities on field, online, on site, at the installation site, with technical training on the product, installation training of our products, always more when it's related to battery and inverters, commissioning trainings through the various platforms that we use for the different products. We run webinars like today, road shows, touching the main cities or areas in the region, supporting our partners locally with introducing of new products, new solutions. And at trade shows, obviously, we try to be present at every trade shows, the main trade shows in the MEA region. Commissioning support, so during the commissioning of our products, obviously, we are at your site locally or remotely. We do have a full team to support technically on site and online for any needs during installation or even after the installation of our products with our after-sales service. And the last step that we did, and which is the focus also of this webinar today, is our configuration and design tool, the quick configurator, which we already seen in the previous session of the webinar, to integrate in your project all our products from modules to inverters to storage systems, and our design tool, which allows really to get into a project and to design and engineer a system with our solutions and our products in detail. Specifically to that, I will leave the deck to my colleague Eid Murak to go ahead and present to you our today's session related to designing a CNI system for self-consumption with our solar and storage products.
All right. Thank you, Andrea. And thank you, everyone, for joining the third session of the series of webinars that we are doing to promote our products inside the power electronics division. So for people who have been following us, we have done a first webinar on residential storage with the all-in-one EPQ. Then we have done a second session on C&I applications, but without storage, using the string inverters that we have in our portfolio. And this third webinar is basically to complete the portfolio with the C&I storage, the KuBank solution that my colleague just introduced. My name is Eid Maraka. I'm engineer of technical sales for the C&I storage. And today we're going to be designing a system together that includes our modules, the inverters, but also adding a storage component to the self-consumption project. So this is the link that you need so that you can follow or access the tool. I have already entered my credentials. If you don't have an account yet, please register, and then you can log in. All right. So this is how the tool looks like. You have two main sections of the Insan tool. One is called string tool. It's more easy to use, and if you need just verification of the string configuration of your inverter, then you go directly to this tool. But you can also add batteries to self-consumption, and then also check the financial part of your project. But if you need a more detailed design, then you go ahead and select the plant configurators, where you can select a certain roof, place modules on it, do 3D design, shading analysis, and also this includes everything that you can do with the string tool, as we're going to see together, plus a couple of more things that you can do additionally. So let's go ahead and start with a little bit easier tool to use, the string tool. Then we go ahead and click on New Project. And as a start, you have to input the basic information of your project. So, for example, the location. But even before starting with the location, I mean, you can you have to enter the name of this project. So we're going to call it webinar C&I storage. And then as a reference, you can just put in here, for example, the date of today, or you can write, for example, project or session number 3. A description, it's a C&I self-consumption, but with storage this time. Then you can plug in the address where you want to do your analysis. So it could be an exact address, so with a like a city, a street number, everything, or you can just put a general one, just a certain city that you have, Madrid, Munich, for example, or any other city. Okay, so I'm going to go ahead and put an address I have checked before, and it's an industrial area in Madrid, which is the same location that I'm going to use also for the 3D tool. So once you select the location, you get automatically the weather data of that particular location, minimum temperature, average over the year, and then the maximum temperature. As you can see, it gets a bit hot in that area, so up to 40 degrees during summer. And then, of course, you can also select the Meteo data provider. So we have Meteonor, but you can also select PVGIS if you want another source. And then the next step would be to define the parameters of your PV field. As you can see, the tool allows you to select up to 3 fields with different characteristics. So automatically you have the first field activated, where you can plug in the parameters of your first field. If you need another field, then you just have to activate it by ticking those boxes. Okay. So for our webinar, we're going to do 2 PV fields with different parameters. So the first one is the azimuth angle, or the orientation of our panels. 0 degrees means south, and if you need more information, you can just click here so that you can get an idea of how the tool introduces or presents the angles for orientation, but also for tilt or inclination angle of the panels. So 0 degrees, as we said, is perfect south. So I'm going to keep it like this, but I'm going to add a tilt to this roof. So maybe 10 degrees or 15 degrees. And then I can select the installation type, if it's freestanding, standing, or roof mounted. I'm going to go for roof mounted. And then we're going to go ahead and select the module type, okay, the PV module that we're going to use. So by default, the only, let's say, PV modules that are available in our database are our own modules. So if you go and click here, you're going to see all the modules that we have in our portfolio. If you have a specific module that you would like to use with our inverters and also with our storage products, then you can tick this box here, and then you have to manually enter all the data of your PV panel. Okay, so I've already selected Canadian Solar, then I select the module series. I'm going to go with the series of 6.2, top Haiku 6, 6.2, 48 TD, and 460. And then after that, I put how many modules I want to have in my first PV field. So if I click like 200, for example, then I get around 92. Maybe I add a little bit more, maybe 250. So that maybe we can use the bigger inverters in our system. I'm gonna get a bit bigger. So yeah, let's go for 300. So for with 300 modules of this type, the top Haiku 6.2 and 460 watts peak, and then we get 138 kilowatts peak for the first PV field, and then we can start plugging in the numbers of the second PV field. They could be the same numbers, really depends on the location that you have, but let's select something a little bit different since we are not doing any 3D analysis here. So let's say the system is 25 degrees from the south towards the east, and then we can give it a tilt angle of 20 or 10 degrees. Okay, I'll select it also as roof mounted, and I'm going to use the same PV module that I have selected in the previous one. Yeah, and maybe go for 320 modules. So we have a little bit more power in the second PV field. And yeah, with this, we finish the DC part of our installation. And then we can go ahead and select our inverters. So when you click on this drop-down menu, you would see all the inverters that we have in our portfolio. So those two systems are the EP Cube, the single phase and the three phase with storage integrated inside. But for this webinar, we're going to go with the string inverters, of course, the big ones, the 100 to 120 kilowatts, which are the biggest inverters in the C&I segment for Canadian Solar. Then it shows you all the models that we have available. So we have 100, 110, and 120. And as you can see, we have two versions of each of those inverters. The A version comes with 6 MPPTs and 40 amps, allows current of 40 amps per MPPT. And then the second version, it's version B with 9 MPPTs and 32 amps per MPPT. For my project, I'm going to select the 120 with version B, so 9 MPPTs and 32 amps per MPPT. Those modules, they come with a not a huge MPPT current or short circuit current, so 32 amps per MPPT should be enough. I'm going to go ahead and click next. And now I have to select how many inverters I want for my project. As you can see, it's recommending me that I select or go ahead with 2 inverters with a DC to AC ratio of 1.18. It's worth saying that the inverters of Canadian Solar, they can use a DC to AC ratio of up to 1.5. So something to keep in mind when you do your own design. It's already built in and integrated into the tool. So I'm going to hit confirm. And then as you can see for PV field 0, which is the first one, I have 300 modules to assign to the different inputs of the inverter. And then I have PV field 1, which is essentially PV field 2, as in the previous page. I have 320 modules that I have to assign to a second inverter. So as you can see here, I have the first inverter with the different MPPTs, okay, up to 9, and then I start with inverter 2. So automatically you're going to see that you have PV field 0 assigned to the first inverter, and then you have PV field 1 assigned to the second inverter. If you want to do a different configuration, you just have to select the PV field from the drop down menu. Okay, so if I click on any configuration, so this is for example 2. When I say 2 and 13, so 2 times 13, we have 26 per MPPT. Then you can see that the number of modules here decreased, and I have to get this number to 0 for both inverters. Okay, I can do this manually. All right. Basically, anything that is in green, it's a configuration that is permitted according to the technical specs of the inverter, and anything that is in orange, it's we are exceeding the DC to AC ratio of the inverter. So as you can see with my assignments of the modules, I still have 44. So I didn't do it efficiently, although I can go ahead and try it one by one. But another way to do it is to do it automatically. Then I can just click on calculate, and it chooses the best configuration of all of them. Okay. So now I'm done with the first inverter. Then I have to do the same thing for, or I can do the same thing for the second inverter or the second PV field. Then I click on calculate. All right, so I'll input the details very quick. Webinar, C&I storage, project 3, and then C&I self-consumption with storage. I'll enter the same location. All right. So as I said, azimuth 0 degrees is south. The tilt, I put it to 10 degrees. I'll do it as roof mounted. Then I'll select the same module from before. So the 6.2 top haiku of 460 watt peak. Then I'm gonna go ahead and go with 300 modules as I've done before. I'm not gonna activate with the second field. I'll go directly and select the same inverter that which we have chosen before. One inverter should be enough for this one. Then I'm gonna go ahead and do it manually. 8. Let me see how many I have left. Okay, I've chosen many more as I was supposed to do. Okay, -2, so I'm gonna do this with 36 modules. Now I have 0. I hope it runs smoothly this time. All right. Yeah, so now we have the yield results loaded here. I mean, in this simple report or in this simple summary, you see the data of your PV field, the type of modules that you have selected, and then also some data about the production of your PV plant, expected losses, and also how you have assigned the modules to the different MPPTs. Okay, so a next step would be to add a self-consumption component and also some financial analysis. To do that, you just have to tick the boxes here. So add self-consumption, and then add financial, and then just a reminder for you also, try to save your work every time that you finish a section. This way, if anything unexpected happens, then you have at least your work saved. Then you can continue from that point on. All right. So yeah, for to do this self-consumption part, there are different ways to do it. You either calculate it based on the loads that you have, but this is more, I would say, optimized for residential applications. Although you still have um, you still have the opportunity to do to divide your consumption based on 3 periods for the different months, or you can do just two time periods, or a peak and off peak. But for our webinar, I'm going to go ahead and upload, which is also an option that you have available. You can upload a whole profile. They need to be hourly data points. So for a typical year, you need 8,760 data points as one column. Can be a CSV, Excel, or if you have also data recorded every 15 minutes, then you can select this option. But the file that I have prepared, which is a consumption for a C&I application, it's as an Excel file. I'm going to go and upload this profile. I click open, and then I can also click on view consumption profile and see how this load looks like on during different months. Okay. If I click on reload graph here, then basically I can see the data. I can see the data without the storage components. So how much of our consumption is covered by PV on different months. Okay. So if you check out this pie chart, then you can see for January you have low irradiance. Then around 85% of your electricity comes from the grid. But then in months of summer, for example, then yeah, a much bigger component of self-consumption you have is covered by your PV. But for this webinar, we're not going to only have PV, but we would like to add a storage component to it. So I'll go and add a storage component. Okay, as I said, for some inconveniences that we have faced, I mean, usually here you have a more exact number of how much battery you would be needing. So the PV field that I was planning to do is a much bigger one. So we're talking about 250 kilowatts peak, or more or less. So basically, you would be having more more surplus. You would be having surplus of PV generation, where basically storage makes much more sense. Okay, so the only option that you have, or you have two options basically. You have the KuBank and the AP Cube. We're gonna go with the KuBank, although as you can see, I mean, the PV generation is barely covering the load that we have. But it's for the sake of this webinar, so we're gonna add one KuBank, which is an AC coupled solution, energy storage solution for C&I applications. It's a 100 kilowatt, 247 kilowatt hour with 247 kilowatt hour storage capacity. So after I choose this, adding storage to the project, then I need to reload the graph. Basically, any change that I do, I need to reload my graph. And then here you can see that we have a new component here in the production of PV that goes to storage. It's a little bit small, as I said, because the battery is a little bit oversized for this project. So, but you can check basically different months. For example, in March, around 12% of the production goes to the battery, and then also in the consumption part, a small, very small part is discharged from the batteries to the loads that we have. Okay. Yeah. So with this, we finished the self-consumption part. I need to save before I can move on to the financial section. All right, so this is how the financial section looks like. You can select the number of years that you are planning for your project, and then you can start with the capex part, so the PV system costs. So you can either do it simplified, where you can put everything that is related to the PV system, from modules to inverters to cabling to the battery itself, here as a euro per kilowatt peak, and this is what I'm going to do for this project. So I'm going to estimate around 750 euros per kilowatt peak. I can add an annual fixed maintenance component around 100 euros. Then the battery costs, as if you have been following me in the previous webinars, battery cost basically refers to the cost of the battery, but of its replacement. Basically, the tool should be calculating the minimum state of health that the battery can operate with, and that would be basically the last operating point of the battery, and that's basically where the replacement needs to take place at the cost that you're gonna introduce here in this field. So I'm not gonna change this one as a degradation profile. You can just estimate 2% for annually for the battery, and then here you have the total your total investment. If you click on detail, then you can do detailed breakdown of all the system costs. Okay. If you have any financing for your project, then you can enter all the your financial data, the amount that is being financed, the inflation rate, the interest rate, everything. Okay. If you have any grants also for your project, then you can do it either yearly, specifying the period and like for how many years you have this grant, and also how much of the capex it's covering, or you can do it as only one amount. If you have also any additional grant that differs from the first one, then you can do that. And then we go to the electricity purchase prices and feed-in tariffs. So you can specify at which price do you buy your electricity. It depends on where you are located. I'm going to go ahead and select 0.15 euros per kilowatt hours. Electricity sale prices also depends on the tariff that you have, but I'm going to put 0.04 euros per kilowatt hours. If you have any feed-in tariffs, you can put it as how many euros per kilowatt hours and what's the duration. Okay. If you don't have any permit to export the energy towards the grid, then you can just put this component as 0. Okay. Then you can also do some detailed modeling if you have different electricity prices based on the time period. Then I'm gonna go ahead and click calculate. All right, so for this system that we have designed, we have a yearly return of around 8%. You can see we have a payback period of around 6 years. Everything is based on the data that I have entered in this model. Of course, you have to use your own data, or basically your customers' load profile, detailed electricity buy and sell prices, so that you can basically get a more detailed idea on or get more insights into your project. Yeah, so basically with this, we finished the first part. I'm going to save, and then I have the opportunity to export it, everything that I have done here in a PDF form. Okay, so as you can see, this is the PDF, the results of the analysis that we have done with all all the system data, all the also the production and consumption, where does it come from, if we are injecting any electricity into the grid, if we are when we are buying from the grid, and with which percentage, but also you can see the cash flow diagram that you have generated based on the inputs, technical and but also economic and financial parameters. Okay, so yeah, now let's move to the more detailed design using the plant configurator. I'll click new, and then I'll call it C&I webinar third reference. As I said, I mean, you can put anything that, or if you have, if you're going to be preparing proposals for different customers, then you can, and you want to assign reference numbers to each one of them, then you can do that. So I'll put 11th of March. Then C&I is this time it's not without storage, but with storage. And then I'll go to the I'll input the address that I talked about, which is the same one as the previous one. Okay. It's an industrial area in Madrid, as you can see. There are many interesting buildings where we can do this this analysis. I'll go for this roof. Okay. Then I click on it so that yeah, using this using the mouse, and then I see the flag directly on the roof that I'm going to be using. Okay, I click on create. All right, so yeah, you can zoom in and out to see the roof properly. You can also use the scroller of the mouse if you want to move right and left, but also if you want to do zoom in when you go to 3D mode, which we're going to see in a bit. So the very first step of doing this design, that you have to create your own roof. Okay, so I click on sketch. I have a list of predefined shapes that I can use, or I can just do it manually as a polygon. Okay, start to the first side. I'm gonna go skip this obstacle that I have here because I'm not gonna place any modules on it. Although I can include it so that it's part also of my shading analysis. Yeah, so now we have our own roof. We have to create the building itself so that we have also a 3D view of it. We have seen this residential type in the first webinar, and in the second webinar we have seen an industrial type, so a flat one, and I'm gonna go also with a flat one this time. So you can enter the details of your building. So what's the wall height and what's the parapet height? For people who don't know, the parapet is basically the edges of the building, because sometimes I mean you need to know that, especially if they are causing any shading on the modules that you have. So yeah, 0.3 is okay. I'm gonna go ahead with 0.4. Then I'll create the building. We cannot see it, but the building is already created because we are already in 2D mode. But if I go to the 3D mode, then I can see that this building that we are interested in is it's lifted up. Okay, then basically using the mouse, the right click, and I can move also the arrows right and left. So I'll go back to the 2D. For with this button and the transparency, you can change the transparency of the roof. So if you put the transparency to the minimum, you can basically get an idea of what type of objects that you have on the roof. So for this webinar, I'm gonna only focus on this big, probably HVAC system, or yeah, some object that could cause some shading to my modules. Then I click on it and place it on the roof. Okay, I can zoom in and so that I can try to get it in the same place. I can also duplicate it, so I can scale it. So we need to scale it, of course, basically changing the width and the length. Okay, and I can also change its height if I would like to. So if I click here, then I can see also third dimension. Okay, so I'll have it at around 1.5. Okay, then I'll go back to the 2D mode, then back to my roof. I'll put the transparency to the maximum, to the minimum. No, sorry, to well, basically, if I put the transparency to the maximum, then I can see it through. But now it's to the minimum. Yeah, maybe I can also add some other objects like trees, for example, so that I can cause some shading analysis. As you can see, this is the south or southeast. So we're gonna place the modules right here. So I can place the tree in here right in front of the building, and if I wanna just change, if I wanna change its dimensions, and I click here, then I can change its height. So now I have it at 19. I can just put 14. Okay, and then I'll go back to the 2D mode, and then I have to select the mounting type that I have. Okay, so for this one, all right, so I'll go and select the mounting type. So as you can see, it's a flat roof also, as in the previous webinar. And then I can also adjust data like the inclination angle, how many modules I want to have in the same row. So I'll keep it as one, and then I'll put this as 10 degrees. Then I go and select the module that I'm interested in. So I'll go ahead and select the same module, the 6.2 with 460 watt peak. Then I click on Create Prototype. All right, so now I have the option of fitting the modules on the roof. Okay, so now it's waiting for me to choose the roof that I want to use. Since I have only created one, so this is the only option that I have. So if I click on it, then I have some more parameters that I can adjust. For example, from where do I want to start my design, and also the vertical distance between one row and another. So now I have it at 0.68. I can put it as 0.7, for example. Okay, and then I click on Edge, and then it's basically waiting for me to tell it which edge I want to use, like basically for the orientation of the module. So if I click on this one, then my modules are facing not completely south but southeast, and with an azimuth angle of 16.61. So if I'm happy with what I have right here, then I click on place. All right. So here at the top, you can see how many modules you have placed, how many, and what's the total power of your PV field. You can, of course, change whatever you want. I mean, you can add modules, or you can add modules, or you can take out modules. For our exercise or for our webinar, I would like to use two inverters. So maybe I can get rid of this one, this first row, since there will be shading anyway on it. And then now I have 282. Sorry, now I have 270. Should be enough. Okay. So the next step would be to do some shading analysis. I'll click on Simulate Shading. Yeah, as I said in the previous string tool, the more modules that you have, the more inverters and components that you're using, then the more time or computing time it needs. So yeah, I got a loss of 0.72%. I mean, the tree is quite far, and then I took out also the first row of the modules. Here you can see the efficiency of or the losses, so or one minus the losses that you have for each of those modules. I exit, then I go to the selection of the inverter part. I click on string design, then I'm going to use 102 of the 120 kilowatt inverters, version B, so 9 MPPTs and 32 amps per MPPT. I'll click on calculate. Okay, so with two inverters, I have a DC to AC ratio of 1.12, so we are fine. I'll click confirm, and yeah, as you can see, I have two inverters in this configuration on the same roof. So I'll click on calculate, and then now I have all my modules assigned to a different MPPT of one of the two inverters. I'll click on apply to fields. And then we do the cabling part. Okay, so you can either select vertical, horizontal, or the automatic cabling. I'll click automatic cabling and then assign all fields. And now basically I can see how the modules or the different strings are cabled between one and another. I'll save the configuration. Then I click on summary, configuration. I have the option to export the 2D drawings and the single line diagram of this project. Okay, so here you can see a summary of the date the data the project data. So everything that we have generated, including also a photo of the roof with the modules on it and the different obstacles. We can have a glimpse into the technical drawings. Okay, here's the object that we have added, and then you also have the option to add many other types of obstacles. The electrical design, how the modules are cabled between one and another, and then I can also add a self-consumption component and do some financial analysis for this with this section of the tool, the 3D design. So yeah, since I have activated it, It's basically the same window that we have seen in the previous tool, the string configurator, but and I'm also gonna use the same profile as before, not as CSV, but as Excel. So as I said, 8,760 points, representing hourly values for a whole year. Then I click on Reload Graph. Yeah, so here you have you have the load profile, but also the PV generation profile for the different months. This is for January as an example, and we haven't added a storage component yet. Okay, this is for May. You can see how the self-consumption changes throughout the year, and also how the production is used, either to to feed the loads that we have, but uh, to to inject electricity into the grid. But now we're going to add the storage component also, as we have done in the previous one, AC coupled. Um, so now, as you can see, since we have a bigger PV field compared to the previous one, since we were not able to do it properly um, in the previous one, so now you have a recommended capacity of 148 based on the load profile that you have. If you have a bigger plant, then it even makes more sense. Then you can select the KuBank, and then you reload the graph. Okay, so yeah, as you can see here, we have a new addition to our graphs, which is the storage part. So if I go to the average consumption, so there's a consumption. Yeah, this is the part in purple. Okay, so the self-consumption from storage, we have it here, and then can go through the different months to see how much is covered from storage. Um, let's go quickly since we are running out of time. So I'm going to go quickly through the rest of the sections. This is the financing part. Okay, I'm not going to change data. It's basically the same section. You can go through it, plug in even the right data for your project. If you have any questions, then you can also contact us if you need any clarification or if you have feedback. But I would like to show you the additional two sections that we have here. So first one, First one is bill of materials. So everything that you have used in this project, then you have it added to your offer. Then, if you'd like to add more components as part of the bill of materials, then you can just click on Add New, and then it allows you to do that. And then, if you want to do any discounts for your customers or do a little bit more detailed breakdown of the cost, then you can do that. Then the last step would be to create a financial offer. So setting the dates, the dates, and then any discounts or also the VAT, name of the customer, address. If you would like also to highlight any the numbers that you have used for your analysis. Um, when we have done also the shading analysis, there was a moment where we were able to generate a screenshot. Then you can upload it here. You can also add any documentation to your project, like data sheets or manuals or anything relevant. And very relevant here is, for example, the data sheet of the KuBank. Then you can also here enter or say what did you include or what did you exclude in your quotation, any terms of and conditions to your offer. Then in the end, you just click on save and export. And the PDF that will be generated basically includes all information that you have done. Okay, so summary of the PV plant, how much is the specific production, But if you go a little bit more down, then you can see how the self-consumption is done. So you're doing around 57%. 57%. This is the production of PV. So 57% goes directly to loads, 7% goes to the to charge the batteries, and the rest are injected to the grid. So yeah, basically any conditions, any numbers that you have faced or used in this project, then it's summarized here, including the terms and conditions of your project. We are done with this, but I just would like to show you some very small detail before I hand it over to my colleague. So if I click here, then I have the option of sharing it with someone else, but I can also access the documents. Any relevant document to this project is saved here. So if I would like to have a look at any of them, and then also the other part is that you can share it with someone internal or external. Okay, so I don't want to share it with myself, but if you would like, you can also share it with me, and then you give me reading or writing rights, and then you can notify me or your colleagues or your customers, just to tell them like anything basically, or you can add any comments here, check the shading analysis, check the number of modules per string, or yeah, anything that where you have doubts or you would like feedback on, then you can add it here. So yeah, with this, we reached the end of this session. I hope it was helpful, and sorry for the inconvenience that we have faced. But yeah, I mean, I hope you have a more powerful laptop than mine, so that computing won't take much effort. Thank you very much.
Okay, thank you, Eid. Thank you for the presentation. Thank you all for being with us and for staying with us. And it was slightly longer than expected, so we don't have so much time. I don't know if people will stay connected with us. I would say that we can go through just a couple of questions that we got, and all the rest will be probably answered in a separate way. And so I will just summarize in the two main questions. There was someone repeating the same, more or less, topic. So I will just go through the main two, and then we have to then edit it up because we're already exceeding the timing. So the first question is related to the tool, if it can be used also for residential projects and with residential storage. And
Yeah. Yeah, basically the first webinar that we held was for residential projects. So you can do simulations of residential projects using the all-in-one EP Cube. You can also basically choose how many batteries that you have based on the recommendation that you get from the tool. It's possible, yes.
okay. And the second one, which is a very recurrent question that we get during these webinars, is the cost of this software and which type of licenses do we have and are available, if it's single user or multi-users licenses.
Well, it's a great thing that for a tool with so many details and also focus on the Canadian solar products at no cost, basically. So there are no subscription services or anything. So it's at no cost. We have launched it basically to use for our customers to improve their design abilities, and also try to get an insight into the different products that we are launching into the market, from PV modules, inverters, and also energy storage.
Okay, and then the last one, since we cannot exceed more than 5 minutes, is related to how to send reports, proposals, and design to an external user. But I think that it went through the last few minutes on this topic, showing how you can export in a PDF and share it via email or directly in the tool, share the project with the Canadian Solar Tech Support for any type of advice with a comment that you just mentioned and you just share also with the participants a few minutes ago. I think it's all for this webinar. Thank you all one more time, and feel free to contact us for any specific needs requests or specific support that you might need on the on the design tool, share your projects with us, with our tech support, and we will be happy to help you and support you during your design phase of your solar or storage project. Thanks a lot, and see you to the next webinar soon.